Hi everyone, welcome back to my channel Code with Bugs. Today I'm going to show you something super cool actually. So we'll be learning about MCP server also. We'll be learning a little more about agentic flow. So as a part of it, we will be using our paint. So just before to that, to give context on what MCP is. So it's a model context protocol. So where we expose the functionality of some tools which are available so that LLM doesn't need to take some probabilistic decisions or some predictive things. It can actually use the tools that are available, as in if we want to go for any calculator, or if we want to search something, if we want to do web scraping, etc things. So we don't need to go for probabilistic methods. So there are already tools that are available, and LLM can have an access to those tools. Then it can use those tools and execute it properly. uh, so that thing can be achieved by using MCPs. And as you see in the current code, we'll be taking a problem statement. And for the problem statement, so I have written three different files, so in which two are only important, so other thing is just an intermediate one. Maybe we'll have a walkthrough of our problem statement, and then how we are solving it using MCP concept, also where we are using the agentic flow, right? So here we have MCP server.py, where we expose the tools as an FSC. So we use a decorator like this, and we uh, then just write the functionality of a particular thing. Then we can use that as a tool where LLM can get exposure to this MCP tools, and then it can use one of the tools that is available to take a call, and use it for exactly returning the proper thing, so that it doesn't need to uh, it doesn't need to use the probabilistic way on how it is actually returning until now. Then as a part of it, so this just looks like this. And as I mentioned, we will be using paint. So what we'll be doing is we do some math, and then we open paint, and then we write whatever the results that we got in math in the paint. So that's like a very high end problem statement that we'll be solving. So as a part of it, if we see, I'm writing draw rectangle function, and then um, paint, add text in paint, and then open paint. So these are the functions that are already uh, there. Maybe we can write these things as an exposure, and then as a tool we can expose it so that the client can receive whatever they are there in the server, and it can our LLM can actually predict what tool it can use it, and then use those tools with arguments. Right. So there are these two things. So one is a talk to MCP. So this is from client side. So our problem statement will be, so there will be a string where we'll be using the string to the end using ASCII values, and then do some math like exponential, and then sum it, and then get some value and write it in the paint as I mentioned. So this is having actually two flows. So first flow is this getting math, and the second is opening paint. So first, here in this particular thing, we are having manual work. First thing will be taken care until math. It will be taken care by agent on which LLM to call, which tool to call, and then after it gets executed, after we get the final answer, we will be going for paint. So this will be like this. So when we just gave that, okay, you need to call functions itself, and then use the parameters or arguments that are required to the functions, and it uses that. So in the second code, these two are actually standalone code, so we can use any one of that. So this second one is more matured. So we are using multi-phase agents here. So two agentic flows we have. So one takes care of math, and then the other takes care of uh, paint, right? right? So maybe we can have a prompt. So there is system math and system paint, where we finish after finishing math, we will be going for paint. So this is a flow for it. So for this, we need to have two functionality, um, two files that are to be executed. So first is mcp server.py. So that I anyway started, and then as soon as we started, it this client will get exposure to the server that we have, and then it will start giving us uh, so if we see after running the math, it opened paint by itself and drawn rectangle and then writing some text here. Then let's go through the logs once again to understand what it has done. So there are two phases. So one is, as I mentioned, math, and then there is a paint, two agentic flows. So first is we convert it into strings. So the strings to chars to int is called, and then int list to exponential sum is called. So where we are converting this ints to exponential, and this is the final thing that we got. So which is executed as a final one for the math phase. Then started the paint phase, where we are seeing that okay, now the tasks are related to paint. So first you open the paint, and then open as you opened it, so draw a rectangle in this particular coordinates, then write the text whatever we have got it as an output from the math calculations. That's the thing that we are getting here. uh, so yeah, it's so cool to see how MCP, with the help of MCP, our LLM got one more superpower to actually call the tools which are there in the MCP site. Uh, yeah, so whatever is available, not just paint, so whatever is available as a tool, we can just use it uh, as an MCP, and then have an agentic flow. Yeah, so this code actually has one more step as well. So previously we were using manual orchestration, but here we've built an agentic loop. So where it takes care of everything. The loop will takes care of everything. And if you are more interested, I'll be posting the GitHub link as well. Please go through that. You can run either the last one, talk to MCP client, or talk to MCP client agent.py, and the clear instructions are there in readme.md as well. So please follow that. And yeah, so let me know if there are any other cool things that you can find it in our piece itself, where you can use MCP and agentic concept to uh, achieve a lot more things. Yeah, thanks everyone. That's all for today. Bye bye.